Okay, this video is video number 2 for section 2.4. So we spent a lot of time in the first part of 2.4 talking about tangent lines. And now we're just going to add one more concept, which is the normal line. So think about a curve like I'm showing here. And at a point, this would be our tangent line, what I have labeled tangent here. And our definition up here says the normal line to a curve at a point is the line perpendicular. So that's the important part, to the tangent line. So if this is my tangent line, let me grab another color here. This line perpendicular to it is my normal line. And what do we know about perpendicular, the slope of perpendicular lines? The slopes are opposite reciprocals. So for example, if the slope of my tangent line is 2, the slope of my normal line will be the opposite and the reciprocal. So it would be -1/2. So the problems will have you finding the tangent line and then writing an equation for the tangent line and then writing the equation for the normal line. So in order to do that, you need the slope of the tangent line to begin with. So the next problem, this is written all over, so let me get a blank here to do this problem on. So the example says write an equation for the normal line to the curve, and this is our curve. Well, before we can write an equation for the normal line, we need to find the slope of the tangent line, then take the opposite reciprocal and write the equation for the normal line. So to find the slope of the tangent line, we're using our regular formula here that we've used already. And for our problem, our x is equal to 1. So we're going to be finding the limit as h approaches 0 of f of 1 plus h minus f of 1 all over h. So I like to, like I showed you in these other examples, I like to do these in parts. So first I like to find the f of 1 plus h, and then the f of 1, and then substitute them back into the limit. So f of 1 plus h means I'm taking my function here, and wherever there's an x, I'm going to substitute in 1 plus h. So I'm going to have that. And then I'm going to do some algebra on this, and I'm going to end up with 4 minus h squared plus 2h plus 1. I wrote it in standard form with the h squared first. And then I'm going to distribute that negative and combine like terms, and I'm going to end up with 4 minus h squared minus 2h plus 3. So this is f of 1 plus h. Move this down. Now f of 1 just means I'm plugging 1 into my function here. So that's going to be 4 minus 1 to the third, or 3. So you can think the coordinate point is 1, 3. Okay, now let's substitute this and this into this function. So f of 1 plus h, we decided, was all of this. So that would be 4 minus h. Oh, this 4 should be gone. I combined it with that 1. So that 4 would be gone. And I would have negative h squared minus 2h plus 3 minus f of 1 would be minus 3 all over h. Okay, so let me just go back here and explain. I distributed the negative, and then I combined the -1 and the 4, and that's where that 3 came from, so I shouldn't have written that 4 there. Okay, now let's simplify another step here. So I'm here now. I'm going to divide this h into both of these terms, and my 3 and -3 cancel out. Now you'll start to notice a pattern in these problems. When I get to this step, I should have h's in both of these terms in the numerator and then divide the h in the denominator into those. So if I had a term up here that didn't have an h in it, I would have a mistake. That's how I knew right away that this 4 didn't belong. So negative h squared divided by h would just be negative h, and negative 2h divided by h would just be negative 2. So now I can take the limit, can substitute in 0, and I'd have negative 0 minus 2 equals negative 2. So that is the slope of the tangent line. Okay, the problem asked me to write an equation for the normal line. So the normal line is going to have a slope of opposite sign, so positive 1 over 2. So that's my m for my normal line, and my point is still the same point I'm using here, 1, 3. So my equation is going to be y equals 1/2 x minus 1 plus 3, or in point slope form, in slope intercept form, right, y equals 1/2 x plus 5 over 2. So that's the equation for my normal line. Right, another application for these problems are speed problems. We're going to do a ton more of these speed problems as we go on, but the speed problem is an instantaneous rate of change. And remember, instantaneous rate of change, that's when it's actually derivative, but right now we're still going to say it's the slope of the tangent line at a point, right? Okay, and also speed, you might know this from physics, is the absolute value of velocity. So speed is always positive. So where's the problem here? Here it is. Find the speed of a falling rock with the equation 16x squared at x equals 1. So this is our same limit as h approaches 0 of f of 1 plus h, because our x is 1, minus f of 1 all over h. Okay, so I encourage you to find these parts separately on your own, and then you can see how I get what I get right now. So I'm going to say we have the limit as h approaches 0, and I already did the algebra for this, and what I have is 16 1 plus h squared minus 16 times 1 squared over h. Well, I didn't do all of the algebra. You can see that I'm just substituting 1 plus h into the function and 1 in here. Now this is where I'm going to skip some steps. Limit of 16h squared plus 2h over h, and I guess I'll go right here. Limit, if I divide my h here, I'm going to have 16 times h plus 2, and this is as h approaches 0. So when I finally take my limit, what I'm going to end up with is 0 in here, so 16 times 2, I'm going to end up with 32. Okay, now let's think about what this 32 is. So we said here that speed is the instantaneous rate of change. So this that we just found, the instantaneous rate of change, is the speed, and this is also the slope. Remember, instantaneous rate of change is the slope at a point. But you can also think of this as speed, and because this was a word problem, we can't just leave this 32, we have to give it some units. So we know we're over seconds here, and somewhere in here it should have said feet. It didn't, but it is feet per second. So this is the speed at x equals 1. Instantaneous rate of change is speed, and in this example it's 32 feet per second. That is the end of chapter 1. But what I also want to do in this video is do 1-2-4 homework problem with you. This is the one I planned on doing in class but didn't get to it. So this is number 11. You have problems similar to this. And so in this problem, we're given a function, we're given a point, and we're asked to find the slope of the tangent line at the point, write an equation of the tangent line, write an equation of the normal line, and graph it. So I am going to actually show you part D, the graph, first, because I graphed this right here. So this is the function, the curvy one here, the purple one. Here is, oops, I put it at yeah, x equals 2 is the point we're looking at. So this is the point we're looking at. So my tangent line to that point is right here. And then my normal line is going to go through the same point and be perpendicular to my tangent. So there's my normal line. So that's the graph they're looking at, but I think it's helpful to look at the picture before you actually start solving. Okay, so we're doing our slope of a tangent line. So we're looking at the limit as h approaches 0 of f of 2 plus h, because we're starting with we're starting at x equals 2, minus f of 2 all over h. Okay, now I'm going to do the two separate parts, just because I like to do it that way. So f of 2 plus h is going to be plugging 2 plus h in place of x here. So I'm going to have 1 over 2 plus h minus 1. And down here I'm going to have 2 minus 1, so that would just simplify to 1 over h. Okay? And then f of 2 is just going to be plugging 2 into this function. So I'm going to have 1 over 2 minus 1, which is just 1 over 1, which is just 1. So f of 2 equals 1, or you can think the coordinate point, oops, 2 comma 1 is the coordinate point. Alright, now back up here to my limit, and let's plug in the pieces. So f of 2 plus h, this should be plus 1 down here. Sorry about that. 2 minus 1 is 1, so I would have 1 over h plus 1, not just 1 over h. So 1 over h plus 1, that's my f of 2 plus h, minus f of 2. F of 2 we said was 1, and everything all over h. Okay, now up here I want to get a common denominator and combine those. So the common denominator is going to be h plus 1. So I'm going to multiply the top and bottom of this times h plus 1. So I'm going to end up with 1 minus h plus 1 all over h plus 1. And all of that is over h. Okay, and I'm going to keep simplifying. Limit as h approaches 0. So this, I have to distribute that negative. So I'm going to end up with 1 minus h minus 1 over h plus 1. And then this divided by h down here, I'm going to write that as just 1 over h. Dividing by h is the same as multiplying by 1 over h. So limit as h approaches 0. So I have a positive 1 here and a negative 1, so those are going to cancel. And I have an h on the bottom here and an h on the top here, so those are going to cancel. So I'm going to end up with negative negative 1 over h plus 1. Yes. And now I can take the limit. I can substitute 0 in here. So I'd have negative 1 over 0 plus 1 equals negative 1. So this is my slope. So m equals -1 at x equals 2. So part A said write, I think part A said just find the slope. So that would be part A. Part B said write an equation. So I'm going to do part B over here. And so my slope is -1 and my point, where's my point, is 2, 1. So my equation is going to be y equals -1, x minus 2 plus 1, which would be y equals -x plus 2 plus 1, y equals -x plus 3. So that is the slope of my tangent line, or the equation of my tangent line. And then part C said write an equation of the normal line. So for the normal line, my slope is going to be opposite reciprocal. So I'm going to have that, which is just going to end up simplifying to just 1. Negative of a negative is a 1. So my slope is 1, and I'm using the same point, because like we showed on the picture, it goes through that same point. So I'm just going to write an equation with these two. So this would be 1 times x minus 2 plus 1. So that would be y equals x minus 2 plus 1, y equals x minus 1. So this is the slope of the normal line. And then part D was just to graph it. So this is a very typical 2-4 in even the early parts of chapter 3. This is what these problems will be looking at. And that is it for the second video for 2-4. And that should be good for you to start all your homework on.